So hello class, this lesson is on, just like yesterday, the fundamental theorem of calculus, but in this particular case we're going to talk about it while using U substitution. So usually instead of going over these steps, what I do is I do these problems, and what I do is basically guide you through the steps as I figure out the problem. So let's do step one. So step one, you see it's a definite, what they call a definite integral because I have bounds, but I'm going to solve it. And just like we've been talking about before, I can't solve this without, there's no rule for this. So what I have to do is I'm going to have to use U substitution. And some of you say like, oh, I don't want to do U substitution. But it's okay, you can do this. So what I'm going to do is I'm going to pick a U. Remember, the best U's to use are the ones that are either underneath a radical or in a parentheses. So in this particular problem, I'm going to make U 27 minus 19x squared. Because that's my U, du, which is again the derivative of U, is going to be minus 38x dx. Now, when I plug this in back into the problem, you'll notice that I have an x dx in the problem. So what I'm going to have to do is I'm going to have to get x dx by itself in that last equation that I wrote down. So what I'll do is get x dx by itself. It's going to be minus 1/3 over 38 du equals x dx. Again, I'm doing this because I want to make sure that x dx is substituted in the problem. Now, so pay attention here. Here's the part where most people mess up. This is the part where if people go wrong, this is where they're going to go wrong. If I change everything to u, that means I also have to change the bounds. So in this particular problem, you see that the bounds are 0 to 1. So in this particular problem, you'll notice that I have a ux equation. So in this ux equation, what I'm going to do is plug in the bounds into this equation and figure out what my new bounds are. So in this particular case, I have 0 and 1. So I'm going to take 0 and plug it into here. I'm going to take 1. Oops. I'll take 1 sorry. I'll take 1 and plug it into here also. Okay. When I plug 0 into my u equation, I'm going to get 27. And if I plug in 1 into this equation, I'm going to get 8. So those are my bounds. And then I'm going to start plugging in the parts of the problem. This cube root now becomes the cube root of u. And then that x dx now becomes negative 1 over 38 du. So now what I'm going to do is I'm going to factor out the negative 138. Oops. And then this one, to make it something I could derive, I'll call this u to 1/3 du. So again, the biggest mistake people are going to make is forget to change the bounds. Don't forget to change the bounds. Now I'm going to take the antiderivative of 1/3. Again, I'm going to plug in, I'm going to add by 1 and divide by it. This thing that's on the outside, this negative 1 over 38, I'm going to leave it on the outside. When I add 1, this becomes u to the 4/3. And when I divide by 4/3, this becomes 3/4. And again, my bounds are 27 and 8. So that's my new bounds. And then to make this easier on yourself, what you can do is factor out, you can factor out the 3/4. So you see a 3/4 there, I'm going to factor that out. On the outside, I'm going to get a negative 3 over 152. I don't know if that could be, that might be able to, I guess you can't reduce that, but that's a factor that out. And this becomes u to the 4/3. And I don't have a calculator on me. So to solve this, or if you want to just finish the problem, so to speak, remember you plug in 8, you plug in 27, and you subtract the 2. So my answer is going to be negative 3 over 152, parentheses, 8 to the 4/3 minus 27 to the 4/3. I'm running out of space here, so 27 to the 4/3. No. Four-thirds. Okay, so that's how you solve these type of problems. Now, just want to do one more. Again, I don't want to make the videos too long. I just want you to get the gist of it. So let me go back to the second problem, which is over here. Now, again, to figure out the best u, figure out what is underneath the square root or in a parentheses. In this case, it's x squared plus 4. Du then becomes 2x dx by taking the derivative. Again, looking at my problem, I notice my problem has an x dx. So what I'm going to do is make this x dx by itself. So it'll be 1/2 du equals x dx. Now, when I rewrite the problem, what I'm going to do is I'm going to plug this back in. Again, the most dangerous or the biggest mistake people do is forget to change the bounds. To change the bounds, I plug this into my u equals equation and just plug in the x's. This particular case, I have 0 radical 5. If I plug in 0 into the u equals problem, which is up here, if I plug in 0 here, I'm going to get 4. And if I plug in radical 5, I'm going to get 9. Then it becomes 1 over radical u, and my x dx will turn into 1/2 du. Now, just to make this real quick, I'm going to factor out this half. This 1 over radical u becomes u to the negative half du. I'm going to take the antiderivative, I'm going to add 1 and divide by it. This now becomes u to the half by adding 1. And if I divide by half, it becomes 2. And then I get my bounds like so. Again, to make this easier on myself, I'm going to factor out the 2. So 2 times half becomes 1. So this becomes u to the half. Oops. And then when I plug in 9 and 4, what I'm going to get is 3 minus 2. So my answer is 1. So hopefully you all understand how to do these type of problems. If you have any questions, put it below or see me in class. And thank you all for watching.